Hi, I'm Michaela White.
I'm Darren Krolikowski.
And I'm Olivia DiMartino, and we're going to be talking to you today about some of the problems that California is facing with groundwater. First, just a little introduction about what we're going to talk about. I'm going to talk about some basics of what groundwater is in general, and then we're going to talk about the problems that California is actually facing, and then some solutions that would fix the problem. So just a little bit about groundwater first. It's water beneath the Earth's surface, and it's actually 0.6% of the Earth's water. And what happens is the water comes from the surface in the form of maybe precipitation, and it'll sink down to the bottom, and that's what the groundwater is, and it fills in between the grains below the surface. And if you use more than it recharges, then you have a lack of groundwater, and it's stored in the formations underground called aquifers, which I will go into more in next slides. So the groundwater occurs under the water table, and that's between the saturated and unsaturated zones. So above the unsaturated zone is when there isn't water to be filled in between the grains of sand, and then the saturated zone is when there is water, and that's where the groundwater actually occurs. And if there is enough water in the saturated zone, then there can be a well built to extract the groundwater. So here's a picture of the water table and then the groundwater that's underneath it. And so now we're going to talk about what it's stored in, and it's stored in aquifers. And this is groundwater stored in the aquifers, which is bearing rocks under the surface. And how much groundwater there is to be extracted depends on how permeable that the rock is under the Earth's surface. And if there is enough groundwater in the aquifers, that's how they extract the water through the wells. So here's a basic picture of how it works. There's precipitation, and then there's infiltration of the water down into under the surface. And you can see the water table again, and then the groundwater underneath, and there's a well there being built in to extract the water. So now just a little bit about California's groundwater. It's 30 to 46% of the state's water, and some areas with hydrology depend on it 100%. And this is the reason why they're having some problems now. Some people are drilling into the groundwater without restrictions, and it's causing an increased loss of groundwater, which we'll go into more with the problems. Here's a picture of the groundwater, and as you can see, as it's gone on through the years, it's gone down, and the yellow area stands for like a more dry time, so they're facing more problems now.
So the three major problems of groundwater, or lack of groundwater, are there's a decline in river and stream flow, contamination of the well water, and a lack of usable water which can lead to a drought. Groundwater is a real problem in many places of the world. When rainfall is less than normal for several weeks, months, years, the flow of rivers and streams decline, and the depth of the water in wells increases, and that can also lead to the drought. So here's just a picture of ways that the groundwater can become contaminated. You can see that like gas station sewage lines can get into the water. Cars, like the environment of cars makes the water contaminated. So contamination is when man-made products get into the groundwater. A few examples are like gasoline, oil, and chemicals. And exposure to like drinking contaminated groundwater can lead to serious health effects. And then here's another picture of how groundwater is actually extracted. So when there's not enough groundwater coming in, the only water available is contaminated water from like sewage lines and everything. So it makes it hard to like drink healthy water. A drought is a prolonged period of low rainfall which results in a shortage of water. And the National Drought Mitigation Center states that California is still in severe drought conditions. Without active wet years, aquifers can go dry, which would lead to a loss of water reserves.
Now I'm going to talk to you about some of the solutions that California has come up with to try and combat this shortage of groundwater. First of all, the most common thing they do is do wastewater treatment as well as desalinization. That's kind of like a new thing they're trying out. They also use artificial recharge. They also use regulations and fines during the drought and there's a proposed idea for pipelines. I'll get more into that. Here's a diagram that I took from the Fresno Water Resources website, and this is basically the process of one of their treatment plants. And what they do is they bring in the wastewater from residential and commercial facilities, and they put it through this treatment process to basically extract like all the garbage and chemicals, and then they'll actually release it back into irrigation basins that will flow to these recharge areas. And then for the rest of the process, they try and extract the sludge, and they actually use a cogeneration process to power their facilities. They use the methane that's given off from this process to power all the pumps and everything. Also for desalinization, California recently actually built a new desalination facility, and this is the process. They use reverse osmosis to extract the salt from the water, from ocean water, to obtain fresh water. And I think it costs around $1 billion, which seems kind of high, but they're kind of running out of stuff to do. And instead of using fossil fuels, which is commonly used to power these facilities, there's been research done into solar-powered desalinization facilities, so hopefully we'll see some of that in the upcoming years. Artificial recharge, it's basically pumping out water to areas of high permeability so the water can sink down into the groundwater areas. And this map shows the basic geology of California, and there's actually a lot of injection wells, which are wells that actually, instead of pumping water out, they pump water back in this pink area up here in the Merton Formation. They drill down about 350 to 410 feet and pump water back into the groundwater areas. Two examples of recharge areas are Millerton Lake and Pine Flat Reservoir. These two are in the Fresno area in the San Joaquin Valley. I pulled the injection well data from the USGS website. Some regulations and fines. They actually use fines in times of drought. And according to CNN, there's a fine for these 4 communities, Beverly Hills, India, Redlands, and Coachella Valley, that totaled up to $61,000. So it's pretty significant when you're talking about just these cities. They said like $500 a day for overpumping. And then final solution, pipeline would be a really good way to get California water like quickly and efficiently, but it's pretty financially infeasible. Rough estimates cost about $450,000 per mile of pipeline. So if you're talking about running a pipeline from like Seattle or like the Sierra Nevadas or by Colorado, that's going to cost a lot of money because it's going to be a couple hundred miles. But it would be a good way to get water there.
So in conclusion, groundwater basically is water found beneath the Earth's surface and is stored in aquifers, and California is a big user of groundwater in that area.
And the 3 major problems that California is facing are the droughts, contamination of groundwater, and decline in rivers and streams.
And California should be out of trouble by using these wastewater pipeline or desalinization processes. Any questions? And here are references.
Questions? What's most of the groundwater used for in California?
Isn't it like tap water and just
Irrigation.
Yeah, it's probably irrigation. Did you find anything about how they deal with the needs of farmers for water and when they have to put restrictions on?
They use like drip irrigation, I know. So instead of like using those big sprinklers, they'll like just use like less and pump it kind of like underground and stuff like that. And actually that thing I was talking about with the irrigation basins and that treatment facility, they'll like put out that treated water instead of using like the water that's already in the ground.
Anyone else with questions? All right, thank you.